learned before about the mirror formula and the magnification formula, that is 1 by v plus 1 by u is equals to 1 by f, and m is equals to h2 by h1, which is equals to minus v by u. So here Rajashri wants to get an inverted image of height 5 of an object kept at a distance of 30 centimeter from a concave mirror. The focal length of the mirror is 10 centimeter. At what distance from the mirror should she place the screen? What will be the type of the image? And what is the height of the object? So in here, you have been provided with the focal length, the object distance, that is minus 30, height of the image, that is minus 5, image distance v, we have to find it out, and height of the object, that is h1, we have to find it out. So how we are going to find it? With using mirror formula, that is 1 by v plus 1 by u is equals to 1 by f. So we have been provided with f, we have been provided with u, so we have to just put in this formula and we'll be getting the answer. So magnification m is equals to h1 by h2, which is equals to v by u minus v by u. So we have been provided, we have to find h1 in here. So we have to shift all the other variables on the right hand side and the variable which you have to find on the left hand side. So in putting all the formulas, we'll be getting the answer as v is equals to minus 15, h is equals to 10 centimeter. The height of the object is 10 centimeter, thus the image will be real and diminished. Registry has to place the screen 15 centimeter to the left of the mirror. Starting with chapter number 12, that is study of sound. Sound is a form of energy which creates the sensation of hearing in our ears. This energy is in the form of waves. A medium is necessary for the propagation of sound waves. Sound waves give rise to a chain of compression and refraction in the medium. The particles of the medium oscillate about the central or mean positions in a direction parallel to the propagation of the wave. Such waves are called longitudinal waves. On the other hand, in the waves created by dropping a stone in still water, the particles of water oscillate up and down. These oscillations are perpendicular to the direction of propagation of the wave. Such waves are called transverse waves. So, they are given us two definitions of longitudinal waves and the transverse waves, which you have to remember. A sound wave can be shown in the form of a graph. At any moment during the propagation of a sound wave, we would find alternate bands of the compression and rarefaction of the medium, that is, bands of greater and the lesser density. So here you can see the change in density and the change in pressure in the loudspeaker. So the average density of the pressure, here they have given us the wavelength and the waves. The wavelength of the sound waves is indicated by the Greek letter lambda. This is lambda. You can just do it like this. You can just do it like this. You have to remember all these things because these are the notations which which you will be even using in your higher standards. While its frequency is indicated by nu, the amplitude, which is maximum value of the pressure or density, is indicated by a. The time taken for one oscillation of pressure or density at the point in the medium is called a time period and is indicated by t. The value of frequency determines the pitch, high or low, of the sound, while the value of the amplitude determines its strength or loudness. Velocity of sound, the distance covered by a point on the wave, for example, the point of highest density or lowest density in unit time is the velocity of the sound wave. Velocity is given by distance upon time. Any point on the sound wave covers a distance equal to lambda wavelength in time period. Thus the velocity of sound is given by v is equals to nu lambda because 1 by t is equals to nu. Velocity is equals to wavelength by time period. V is equals to lambda by t. Thus the velocity of sound, the velocity of the sound is equals to wavelength into frequency. The velocity of sound in various mediums at 25, that is the normal room temperature. They have compared these in the state they have given like solid, liquid, and gas. The substance they have used in solid is aluminium, nickel, steel, iron, brass, glass, etc. So the speed of the sound, it varies depending upon the substance material. Aluminium speed is 5420, whereas it increases decreases depending upon the material. So in liquid, you can see in liquid it is the slowest, and gaseous is it is the lowest. बहुत ज़्यादा. The Italian physicist Virgilio and Viviani in 1660s first calculated the speed of sound. They measured the time between seeing the flash of a gun and hearing its sound from its long distance. The value of 350 meter per second is very close to the value of 346 meter per second, which is accepted today. Velocity of sound in gaseous medium. Velocity of sound in a gaseous medium depends on the physical conditions, that is, temperature, density of the gas, and its molecular weight. These are the circumstances, these are the situation conditions on which sound depends. Temperature, the velocity of sound is directly proportional to the square root of the temperature of the medium. This means that increasing the temperature four times doubles the velocity. V is directly proportional to root t. Density, the velocity of sound is inversely proportional to the square root of the density. Thus, increasing the density four times reduces the velocity of to half its value. For the molecular weight, the velocity sound is inversely proportional to the square root of the molecular weight of the gas. Thus, increasing the molecular weight four times reduces the velocity rate to half its value. That is why they have used square roots for the same. Think. What you have to think now is the molecular weight of oxygen gas O2 is 32, while the hydrogen gas H2 is 2. Prove that under the same physical conditions, the velocity of sound in hydrogen is 4 times that in oxygen. For a fixed temperature, the velocity of sound does not depend on the pressure of the gas. Audible infra and ultrasound. The limits of hearing of a human ear are 20 Hz to the 20,000 Hz. That is, the human ear can hear sounds of frequencies in this range. These sounds are called audible sounds. Our ears cannot hear sounds of frequencies lower than 20 Hz and higher than 20,000 Hz, 20 kHz. Sound with frequency smaller than 20 Hz is called infrasound. The sound produced by a pendulum and the sound generated by the vibrations of the Earth's crust just before an earthquake are examples of such sounds. So you have to remember all the examples and the values and the frequencies of the same. The sound produced and the sound-based frequencies greater than 20 kHz are called ultrasound. A dog, mouse, bat, dolphin, etc. have a special ability to hear ultrasounds. Thus, they can sense more noise which are inaudible to us. Children under 5 years of age and some creatures and insects can hear waves with frequency up to 25 kHz. Like bats, mice, dolphins, etc. can also produce ultrasound. The ultrasonic sound produced by bats gets reflected on hitting an obstacle. This reflected sound is received by their ears and they can locate the obstacle and estimate its distance even in dark. So you can just see here okay, how they can locate a particular substance or a particular object when where it is situated. What are the uses of ultrasonic sound? For communication between ships at sea, to join plastic surfaces together, to sterilize liquids like milk by killing the bacteria in it so that the milk keeps for a longer duration. Fourth, echocardiography, which studies heartbeats and is based on ultrasonic waves. The sonography technology, to obtain images of internal organs in the human body. In industry, to clean intricate parts of machines where hands cannot reach, locate the cracks and faults in the metal blocks. So As you all can see, okay, what are the uses of ultrasonic sound and how it is important in our day-to-day life and how it is important for the advanced technologies which we have made. Reflection of sound. Light like light waves, sound waves too get reflected from a solid or a liquid surface. These waves also follow the laws of reflection. A smooth or a rough surface is needed for the reflection of sound. The direction of the incident sound wave and reflected sound wave make equal angles with the perpendicular to the surfaces, and all these three lie in the same place. Good and bad reflectors of light. So, how much of the incident sound gets reflected decides whether a reflector is good or bad reflector. A hard and flat surface is a good reflector, while clothes, paper, curtains, carpet, furniture, etc. absorb sound instead of reflecting it, and therefore is called bad reflectors. What is echoing of the sound? An echo is a repetition of an original sound because of reflection by some surfaces. In order to be able to hear the original sound and its reflection distinctly at 22 degrees Celsius, what must the minimum distance be between the source of and the reflecting surface? At 22 degrees Celsius, the velocity of sound in air is 344 meter per second. Our brain retains sound for zero point 0.1 second. Thus, for us to be able to hear a distinct echo, the sound should take more than zero point 0.1 second after starting from the source to get reflected and come back to us. So you have to remember all the circumstances under which we can hear the echoing of the sound. This thus we can determine the minimum distance between the source and the reflecting surface as follows. With the help of formula we can determine it. Distance is equals to speed into time, where the speed is given by 344 meter per second and the time is zero point 0.1 second. So by calculating it, we can easily calculate that is which is equal to 34.4 meters. Thus, to be able to hear a distinct echo, the reflecting surface should be at a minimum distance of half of the above, that is 17.2 meter. As the velocity of sound depends on the temperature of the air, thus this distance depends on the temperature. I'll be just showing you the calculation, how it is being calculated. Here it is, 344 into 0.1. So you can see about the units we'll be seeing, okay? Here it is meter per second and here it is just second. तो we'll be noticing कि यहाँ पे सिर्फ 34.4 मीटर लिखा हुआ है. Why is it cancelling it out? Here it is in the denominator, so this one and this one gets cancelled out, and whereas it is zero point 0.1, while calculating it will just shift its 1 point and it will be 34.4 meter. Okay, the meter, only this unit remains. So in next we'll be continuing the chapter next video. Thank you.